Hi everyone. I hope you are seeing me and hearing me. So thank you for joining us, and it's time to take over this channel with a brand new session. So we are happy to announce that we are giving a collaboration with HST, and we titled as AI Echoes. So before diving into the meeting, we have a program for the students in a local. So that is called Huawei Cloud Acceleration Program starting. So you can just scan this QR code and reach out the information that you required. So I think that's a good opportunity to process and internationally recognize Huawei Cloud certification and make a difference in your career. So today in this session, we will be hosting Dan Vega. Dan Vega, he is a Spring Developer Advocate at Broadcom, and I think I don't need to introduce myself. So it's me, Sefa Bilicier, as I'll be working as an intern at Huawei. It's a long-term internship. So right now I'll be taking Dan Vega to the stage. Just a quick second.
Hello.
Hello, Dan. Welcome to this session. How are you?
Awesome. I'm doing great. Thanks for having me here.
Thank you. We are thank you.
Uh, so I wanted to learn a little bit more about this group. Is this based out of Turkey? Is that correct?
Yeah, based on Turkey, but we just checked the registrations that those are comes from the Egypt. So
Awesome.
yeah, totally.
Yeah, I have. It's just funny. I have a neighbor 2 doors down from me who is originally from Turkey. He goes back there every year. So I was telling him
Wow.
about this last night, and he was really excited. So,
Oh,
yeah, awesome to be here.
that's good. That's good to hear. So I'm giving your screen to the stage. Okay.
All right.
Okay, stage is yours. I'll be at background, and if you have any question or anything, you can just hands you. Okay.
Yeah, and everybody in the audience, please feel free to ask questions. Let's make this interactive. Get your questions in. We'll see if we can't get them answered. So I'm going to start the presentation. I have just a few slides today. I just want to talk about a few high level things, and then we're going to just write some code today. I love looking at code. I love kind of live coding stuff. So we're going to go through a lot of code today. So this is AI for Java developers, building intelligent applications in Java with Spring AI. My name is Dan Vega. I'm a Spring Developer Advocate at Broadcom. A little bit more about me. You can learn some more about me at danvega.dev. That's my personal website. I'm a husband and a father. We live outside of Cleveland. I'm a Java champion. I've been doing this software development thing for a while now. I hate putting that number up there because it makes me feel old, but it is what it is. I'm a Spring Developer Advocate. I've worn a lot of hats in this industry, and this is probably my favorite one that I get to wear because long before I was being paid to do so, I was a Java developer, I was a Spring developer, and I would advocate for those things. One of the things I really like to share with audiences is that you don't need permission to advocate for the things that you're passionate about. So if there's a particular language or a framework or a tool, go out and tell people about it. Give a lunch and learn at your work. Give a talk to a local meetup. Create a video. Join a podcast. Whatever it is, go out and talk about the things that you're passionate about. You never know where they will kind of lead you in your career. I'm a soon-to-be author, writing my first book with my friend Nate Shuda, Fundamentals of Software Engineering, from Coder to Engineer. This is available on the O'Reilly platform now in early access. So if you are a subscriber there, you can go ahead and start reading this book now. We're constantly adding more content to it, and it should come out later this year. If you are in the Spring ecosystem, we have a podcast called Spring Office Hours that me and my friend Deshaun do. And this is really a chance for you to get caught up on all of the things happening in the Spring ecosystem, because it's not just Spring Framework and Spring Boot, it's other projects like Spring AI. And we take the opportunity to kind of talk about what's happening there, as well as answer your questions. This is a live stream that happens every Monday from 1 to 2 Eastern. You can catch the replay on the Spring Developer YouTube channel, and then we also turn this into a podcast. And just one more quick thing. I enjoy talking about AI. I enjoy writing about AI. If you want a free resource, bitesizedai.dev is another newsletter that I run that's completely free, and just for me to a chance to kind of explore AI and write about things that I'm interested in. Cool. So I want to start here. When we talk about AI, I guess I know why, but for some reason, it's usually associated with Python, right? So I even had a customer probably a month or two back, and they were talking about kind of replatforming their entire Java dev team onto Python to take advantage of AI. And I said, whoa, hold on. We don't need to do that. And I think it's important to note that there are different spaces in AI, right? When we talk about AI, at least like with the things that we're going to talk about today, we're talking about generative AI. And so there are all these large language models out there that had to get pre-trained and kind of distilled and fine-tuned. And there's a big difference between kind of building these large language models and consuming them. And I think a lot of us in this space now, especially in the generative AI space, are consumers of these large language models. And that can be done from any language. So most of them have kind of REST endpoints. So we can hit a REST endpoint and take advantage of it. So why Java? Well, when it comes to Java, there's a huge AI opportunity here. Java powers 90% of the Fortune 500 companies' backend systems. I think it's like 95% of the Fortune 100. So Java is in the enterprise, and enterprises are looking to take advantage of AI wherever they can, right? And it's not just a nice to have now. These AI capabilities are expected in enterprise applications. If you work for an enterprise, I'm sure they probably started asking you like, hey, what are the different things we can leverage AI for in some of the products that we have? And so Java developers have a unique market advantage with AI skills. There are a bunch of really great enterprise use cases. The typical one is kind of the chatbot integration, being able to really automate that that feedback, those questions, being able to like have intelligent customer service automation. We're seeing lots of more use cases where, hey, I have all of this internal knowledge, like we have all of our own documentation, we have documents that kind of cover our products, and we want to expose that for knowledge extraction. And then there's, the other side of it for us developers, being able to generate code and build kind of developer productivity tools and really just kind of become more productive as developers. And then really cool things happening in like the enterprise data space, right? We're seeing lots of more of, I was talking with someone on the podcast a couple of weeks ago, and we talked about all of those dashboards that we used to build back in the day. So the enterprise wanted to see all of this data in a particular dashboard, and we had to get all those requirements and kind of build these dashboards with code and make that data available to them. Now we're seeing lots more like dynamic dashboards, right? Like, hey, let the business kind of build their own dashboards based on all of the data that we're pulling in. So some really great use cases in the enterprise. So before we get into even Java and Spring AI, as I mentioned, a lot of these large language models have just a REST endpoint. So we'll be looking at OpenAI, but this is kind of similar across the board. OpenAI has a REST endpoint, so you don't even need a programming language. You can just write this simple bash script. You can say, here is my OpenAI API key. Here's the prompt or the question I want to ask the LLM. So tell me an interesting fact about Java. And you can send a curl request, and it has some data that you have to format a certain way. You send this request off, and you get a response back. So in this kind of all of this data, there's a response in there under the content key, but there's also all this metadata that comes back, like what model am I using? How many prompt tokens or completion tokens? What were the total tokens? We'll talk about what tokens are in a minute, but we get all this data back. So before we even talk about like using Java or using Spring AI, just know that we are now talking about like being consumers of these large language models. And so we can do this from any language or even from a simple curl command. Now we can also do this in Java. So from a Java standpoint, I have just a simple script here. I got an API key. I have my body, which is the request body that I'm going to send off. I'm using the JDK HTTP client that came in JDK 11. I go ahead and create a request. I send it off and I get a response. And similarly, I will get that the response that we saw before back. So from curl, from Java, we can start to consume these large language models. But what I want to talk about today is Spring AI. And I want to make an important kind of distinction here. If that's all we needed to do, we wouldn't need projects like Spring AI. But it turns out when you start building real world applications, there are a bunch of problems that you have to solve for. So Spring AI is much more than a facility for making REST API calls. There are a bunch of tools that Spring AI gives us out of the box. So let's talk about Spring AI and then we'll jump into some code. So Spring AI, AI for Spring developers. And I've been saying that a lot lately, but I also think it's AI for Java developers, right? It is the same way that Spring got me into building enterprise applications as a Java developer. I believe Spring is really a gateway if you are a Java developer to get into building these generative AI applications. So if you want to learn more about it, you can head over to spring.io/projects/spring.ai. This was started by Dr. Mark Pollock. The current version is 1.0.0 milestone 7. If you want to head over to the Spring blog, there was a post recently about this milestone 7. And it said in that post that this is the last milestone release. With upcoming in May, there will be a release candidate quickly followed by a GA. So they said in that post that it would be before Spring I/O in Barcelona, which I'll be at, by the way. So if anybody's there, please come say hi. But the Barcelona is what, the 21st, 22nd? So we will have a GA sometime in May, earlier in May. So that's really exciting that this is a lot of work has gone into this project. And I'm really happy to see that we're hitting 1.0 here real soon. It has a bunch of features, and we're going to go through those today. One of the biggest ones is the portable API support across these AI providers for chat generation, image generation, audio. There's even video coming out, right? And this portable API is very important because if you're paying attention to the AI world, there's all these different companies that have large language models like OpenAI. And it seems like they come out with a new model every week, and it's now like the greatest and latest model that's out there, right? So it's important to have a framework that allows you to write portable abstractions against that code. So when we write code in Spring AI, we are not writing it to a specific vendor or to a specific model. We are writing code underneath the hood. We are configuring what LLM we're going to talk to. And if at any point we want to swap out that OpenAI GPT 4.0 model for, say, Anthropic's Sonnet 3.7, we just change some configuration. We don't change all of the code in our application. And I think that's very important, especially with how fast-paced the AI world is moving these days. There's both a synchronous and a streaming API option. So we'll see that in action today. That is very important. So the synchronous is, hey, I'm going to make a call. I'm going to wait for that response and get it back. The streaming is much more what you're used to when you're using something like ChatGPT. You ask it a question, you immediately start getting a response back. And that's what the streaming option gives you in Spring AI. And Dr. Mark Pollock often says that, hey, this was inspired by Python projects like LangChain and Llama Index. That's all I got. I just wanted to kind of go over high level stuff there. We'll jump into a few other things and some code. But before I do, I want to just see if there are any comments. Doesn't look like it. All right. So I think this is a good place to start. I want to talk about tokens and context windows, just because in case you hear these words, kind of know what they mean. So here I am on chatgpt.com, and I have entered a prompt here that says, tell me an interesting fact about Turkey. So we're going to go ahead and ask ChatGPT that, and we're going to get a response back. This is actually one of the reasoning models. So that O says, hey, this is a reasoning model. It's actually going to think through its response instead of kind of immediately giving us something back. But it'll give us a response. And until we get a response, I'm just going to copy this. And I want to talk about tokens and the context window. So when we talk about a context window, this refers to the amount of text or tokens that the model can see and consider at one time when generating a response. So we have this thing called a context window. And every time we ask a question, that is a user message. So our question that we just copied there is the user message. When ChatGPT responds back, that is the assistant message. There are other types of messages that can contribute to this context window. A system message is some kind of overall context on how you want the model to respond. We'll see an example of that today. Tools give it extra capabilities like the ability to search the web or talk to GitHub or whatever it needs to do. So the reason I bring this up is all these different messages kind of add to the context window. And these are represented in something called a token. And so I wanted to copy this and show you kind of what a token is. So there's some different tools out there that show you how to like visualize tokens. And so if I go ahead and paste that text in there, a token down here, it says, is roughly 3/4 of a word. So 100 tokens roughly translates to 75 words. It's not just, a token is not just a word. And you could see how it's kind of broken down below. So this particular text is 7 tokens. And you can see each of the tokens, and each of the tokens are assigned an ID. So this is important because every single time that we kind of contribute to this, we will be adding tokens to the context. So we can see ChatGPT responded with an interesting fact about Turkey. And if I come back here and I add this to this, so if I go here and I add that, now we're at 83 tokens. And so the reason this is important is because as we keep putting information into this chat, we are adding tokens to the context window. And the context window has a fixed size. And it's also important to note that like tokens are how we pay for this. So when we use like an API, that if you remember from one of my slides, there was some metadata about it, and it said, hey, here are the prompt tokens, which is what I sent. Here's the response tokens, and here are the total tokens. So as we're sending these tokens, this is how we're kind of paying for this. Tokens are the currency of LLMs, right? And it's important to understand context size and tokens, because if you go out and start looking at all of these different large language models, they will have some features like what is the context window size. So for something like GPT 4.5, there's 128,000 tokens that I can have in a window at one time. If you go above that, it won't be able to consider all that text. Conversely, if you go look at something like Gemini, and this should be 2.0 now, it has 1 million and even 2 million token context windows. So context window size matters, and then pricing matters. So something like GPT 4.5 is really expensive. $75 for 1 million tokens in, $150 for 1 million tokens out, compared to something like Gemini 2.0 Flash, which is 10 cents for 1 million tokens in and 40 cents for 1 million tokens out. So if I was building some kind of application that was taking a lot of throughput and high traffic, this is going to matter to me. I might reach for something like Gemini 2.0 Flash. So when you're looking and starting to evaluate all of these large language models, context window and pricing definitely matters. And there's this tokenizer, and you can kind of get a visual representation of what that looks like. Cool. Let me just double check here. Again, if we have any comments, please try and get them in, and we'll see if we can answer them. Okay. I think a good place to start here too is the Spring AI reference documentation. This is a really good place to kind of get familiar with the Spring AI project and what features it has. So if you go into, say, the chat client API and look at AI models and look at chat models, you can see all of the different models that are supported out there. And again, we are writing code specific to Spring AI, not to these models, but we do support all these models. And you can even mix and match. So I know some applications out there that may use one particular large language model for chat, and then another particular model for like image generation. So this is a really good place to start to understand what models are available and how you can kind of get started with them. So we're going to start and create a simple application just to kind of do like a hello world here. If you go over to start.spring.io, you can fill in some data. I'm going to use Java, Maven, Spring Boot 3.4.4, and fill in some metadata about this. And we'll just call this HSD. And then we're just going to pick a couple of dependencies. So I'm going to have a web dependency, and then I'm going to pick my model. So if you start looking at AI, you can see there's things like Azure, Mistral, Stability, Anthropic, Azure, OpenAI, all these different AIs, right? There's even an Ollama. And if you're not familiar with Ollama, I have some videos on my YouTube channel on this. This will allow you to run large language models on your own machine. Now, not these proprietary ones like OpenAI's GPT-4o. Despite the name open, they're not really open. You can't download those models on your machine. But there are a lot of really great open source models out there, like Google's Gemma 3. Meta has Llama 3.3, 4.0. These are models that you can run on your own machine. I have a pretty decent MacBook Pro, and I downloaded like a 7 gigabyte model, and it's extremely fast on my machine. And that gives you a lot of pros and benefits, right? Like, I don't have to pay for it. I don't have to wait for that latency of like calling out to some third-party service, right? So if I'm just like kicking up some kind of MVP that I want to test out, you can go ahead and run things on your own machine. And then maybe when you get to production, you use a different model. So in this case, though, I am going to use OpenAI. So I would select OpenAI. And that's all I need to get started. I can go ahead and generate that project. That will download a zip. And we can open that up in our IDE. So I'm going to do that. I have it ready to go here. And I have my main application class. So again, we are going to configure the large language model that we selected from the dependencies. So all I got to do is come in here and fill out a couple of properties. Now, to do this, if you want to kind of follow this and do this at home, you'll need to get an OpenAI API key. Again, this is, you're going to have to put some money in to use this. If you don't want to do that, you can use Ollama and just use like a local model. But when I'm doing these demos and I'm just kind of running something on my own machine, I put like $10 in OpenAI for this like a year ago and still didn't use those up just for these demos. So it's very inexpensive, but just know that that's on my local machine. Once it goes to production and we start taking high throughput, you know, there are some definite costs that you will incur. So I'm going to go ahead and set my API key. Now, if I had one, I could just kind of hard code it in here, but I have created an environment variable so that I don't leak my key here. And then the only other thing I want to do is set what model I am going to use. So again, with something like OpenAI, and maybe we can take a look at this. OpenAI models. Let's see if we get a list here. So if we look at models, there are all these different models that OpenAI has. So GPT-4.1, O4 Mini, all these different models. And if you want to, you can compare them, and you can even like look at what their pricing is. So there are different models for different use cases. I'm just going to use GPT-4o today. So GPT-4o, and that's all I need to set. That's all I need to set to get up and running. There are obviously a whole bunch of other configurations that you could set. So let's just look at maybe one other one. Let's see, max tokens. Where is that at? So if we talked about tokens. We talked about tokens kind of being the currency of LLMs. If I wanted to maybe configure something in my app to say, hey, the max number of tokens that we can send at one time, or the max number of completion tokens that we should get back at one time is this, so that we're not just allowing someone to like stuff 1 million tokens into the context window. There are configuration options for this, and there are a whole bunch of configuration options. So if you wanted to, you can go over to like the Spring AI reference, and let's say go down to OpenAI. And if you look in here in the documentation, here are a bunch of properties that you could set. But again, the only properties that we need to get up and running are these two. Okay, so with that configuration, we can go ahead and start writing some code. So I'm going to write a chat controller, and this is going to be a REST controller. And the first thing I need is access to a chat client. This is the interface that is going to allow us to talk to the large language model. So I'll say private final chat client, chat client. We will get this through constructor injection. So a chat client is an interface. Builder is a way to kind of construct a chat client. And it turns out that when you have something like OpenAI on the class path, we will configure a default chat client for you. So I can call this builder, and I can say builder.build. And now I have a chat client that I can go ahead and use in my application. So let's, I'm going to copy this question again. And we're going to create a simple chat endpoint. And so this is going to return a string. And so now I can use this chat client. Let's return that. And I can give it a prompt, and I can pass all these different types of messages in here. We saw this earlier when I was talking about the context window. There's a user message, an assistant message, a system message, a tools message, right? There are all these different messages that we can send. In this case, I'm just sending it a simple string, but this is my user message. So I'm going to ask it a question. I'm going to make a call to the large language model. This is going to be a blocking call, but for this one, that's okay. And all I want back is the content. And that'll give me that string, that answer from the large language model. If you remember back to one of those slides, there's a whole bunch of metadata that comes back. This is just telling the system, hey, all I want back is that simple string, the actual response. So that's it. I have a chat client. I create an instance of it using that builder. And then I use that chat client to make a call. Here's the prompt I'm going to give it, and I'm going to get a string response back. So I'm going to go ahead and run this application, and it's started up. And so now all I want to do is make a request to localhost 8080/chat. So I am going to open up a terminal here, and I have a little utility called HTTP-IE. And this just allows me to make a request, similar to curl, but for me, much more readable and easy to understand. So I'm going to say localhost 8080/chat. And we are going to ask it that, and it's going to send this prompt, tell me an interesting fact about Turkey. And here is the response. So with that little bit of code and that little bit of configuring what model we were going to talk to, we are now able to use generative AI in our applications. I think that's really cool. Now, this is a blocking call. So what if I don't want a blocking call? You know, we had to send that response. We had to wait for a second to get a response back, and then we got it back. But if we were building some kind of like chat interface like ChatGPT, we don't want to wait for that entire response to come back, especially if it's going to be a large response. We want to be able to kind of asynchronously get the response back. So we can do that in Spring AI as well. So let's say get mapping /stream. And this is, instead of returning a string, it's going to return a flux of string. This is coming from Webflux. And we're going to have a similar return to this. But what I'm going to do here is, instead of the call method, I'm going to use the stream method. And instead of tell me an interesting fact, I'm going to say tell me 10 interesting facts about Turkey. So again, if it was 10 facts and I ran this on the blocking call, we would have to wait for all of that content to come back. In this case, we can start to get the response back right away. So I'm going to rerun this application. And then from our terminal, we're going to say, actually, I'm going to go ahead and turn on streaming. And we'll say 8080/stream. And right away, we start getting that information back. So we're streaming the response back instead of having to wait for that entire chunk of text to come back. And again, this is a much better user experience for anyone who is using like a chatbot. Cool, just checking here. Any questions? Doesn't look like it. All right. So I'm going to stop this one, and I'm going to go over to another project that I have. This is over on GitHub. Actually, let's go ahead and show that. Spring AI workshop. So that is this. So if you want to go ahead and pull this project, github.com/Dan Vega/Spring AI workshop. This has all of the information, the code that we're going to go through today, but a whole lot more because we're not going to have time to go through all of it. So this is the Spring AI workshop, and this will just allow us to look at some more functionality of Spring AI. Again, I think I pointed this out earlier. If all we were doing was calling a REST API, we wouldn't need projects like Spring AI. But as we start to build out some of these applications, there's going to be a lot of problems that we need to solve for. One of which we already saw, right? Like being able to like stream the response back. Spring AI has a facility for that. So I want to look at some other things here. So I have this prompt example here, and I have this get mapping for a REST controller /post/new. And what I have here is a system message. So I talked about this earlier. If we have these user messages, what if the user message was write me a blog post about some topic? Write me a blog post about JDK virtual threads, right? That would be fine. But what if I wanted to, anytime somebody requested a blog post on a particular topic, I wanted to give the system some overall context. Here's my context. This is the system message. This is saying, hey, if you're asked to write a blog post, I want to be more specific about it. Here's the length and the purpose. Generate 500-word blog posts that inform and engage general audience. Here is the structure. You're going to have an introduction, a body, and a conclusion. Here are the requirements. Here's the tone and style. This is a very simple system message. You can get kind of as extravagant as you want with this, or as detailed as you want. So now when I send a prompt, or when I use that chat client, I'm passing in a system message. And then in the user message, instead of it just being plain text, I can use this prompt user spec to go ahead and set the text. Write me a blog post about some topic. And now you see I have some kind of placeholder here that I will replace later. And then I can pass a param in here, and I'm saying the topic is going to be dogs. So let's just use our example that we just talked about, virtual threads, right? So now I can, if I send this off and we say /post/new, we should get a blog post that isn't just random. It follows our kind of system prompts. So let's try this, post/new. Is that one not there? Git mapping, REST controller. Oh, we are not running. So let's go ahead and run that. We are still running over here. That's our problem. So let's go ahead and run this. And let's say that. So now what we should get back is a 500-ish word blog post with an introduction, 3 main points, and a conclusion. So here's our title, here's our introduction, here's our 3 main points, and then a conclusion. So that's kind of different messages, right? Being able to set a system message, being able to set the user message, and use some variables in there. Cool. All right. The next thing I want to talk about is structured output. And for that, I'm going to come back over to my browser, and I'm going to go over to Google's AI Studio. So if you've never used Google AI Studio, this is kind of their behind the scenes way to like play with some of their large language models. And this is a good opportunity to it's kind of a developer dashboard because you get access to like a lot of their tools. But over here, you can kind of switch through all the different models, and we can take a look at something called structured output here. So I am a basketball fan. My Cleveland Cavaliers are in the playoffs, and I want to ask a question here, like, tell me all of the teams in the NBA. So if I just ask it that question, we haven't really given it any direction to what we want back. So it's just going to be very random, right? I have no idea what it's going to return. And in this case, it just listed out all the teams and it broke it down by their conference and their division. Okay, if I was just using a kind of chat interface and I just wanted an answer, this is perfectly acceptable. But what about when I'm working in an application and I need the data to come back in a particular format, a particular structure? How do we control that? And that's what structured output is. So in here, there's an example of how we can use structured output. And what we're doing here, you can edit the code, or there's this nice visual editor. And what I could say is what I want back is an array of teams. So I want an array of teams, and these teams should have a name and the city that that team plays in. So now if I go ahead and save that and I copy this and run this again, now what I'm going to get back is this JSON object, which has an array of teams. And for each team, there's a city and there's a name. And so now if I know that I'm going to get back this structure every single time, it's much easier to work with in an application. I can turn this into a type, right? And that's really what structured output is about. So I have an example here similar to that. So I have a chat client, and if I have this endpoint called vacation/unstructured. And I was visiting Montreal, Canada, and I said, what's a good vacation plan while I'm in Montreal, Canada for 4 days? I have no idea what's going to come back from that response. It could be any sort of gibberish. It could be in any format it wants to. But if I was using that in an application and I want to like turn that into a type and work with that data, I need to know what's coming back, right? So I have this other endpoint called structured. And instead of just asking for the content back as a string, I pass it this entity. And this entity takes in a type. And so this type is something I've declared below. So an itinerary takes a list of activities, And an activity has the activity, the location, the day, and the time. And so by doing this, we are using structured output underneath the hood. We are saying, I want you to conform your output to this type. And it turns out that every kind of different large language model out there or provider has a different way of dealing with structured output. So underneath the hood, Spring AI is making this very easy for you. You just pass in a type underneath the hood. We kind of send this along with the user message saying, this is the kind of output that I expect back. So if we go ahead and take a look at this example, we're going to go to vacation/structured. And what we should get back is an itinerary that has a list of activities, and then each of those activities have those kind of different properties. So the activity is explore Old Montreal. This is on day 1. Here's the location. Here's the time. Here's the second activity. And so it's really kind of given us everything we want back as a type. And again, as a Java developer, as somebody who's building applications, you're going to want to work with types, and Spring AI makes it very easy to do that. Cool. I think the next thing I want to look at is kind of talking about bringing, actually, let me jump into multi-model and then we'll go to bring your own data. So everything that we've done so far has been with text. But a lot of these large language models have the ability to work with multimodalities, text, chat, images, audio, video, etc. So I have another example here where, again, I just get access to a chat client. I am using this resource called a sample image. And this is just in an images directory. And if you look at this, you can see what the image looks like. It's kind of this little cozy nook with a laptop, glasses, a latte. And what I want to do is I want to ask the large language model to go ahead and explain what it sees in the following image. So again, I'm passing this user prompt. This is the prompt. Part of this is I can attach media to it. So I'm attaching a JPEG. I'm attaching this image, and it will send this along as part of the request. So if we run this, which is /image to text, we should have the LLM be able to describe what's in that image. So let's say image to text. And this will take a second. It's going to look at the image, kind of see find out what is in that image, and then respond. So the image shows a cozy setup with a laptop placed on a bed. In front of the laptop, there's a wooden tray holding a pair of eyeglasses and a gray mug filled with coffee, which has latte art on the top. The setting suggests a relaxed or casual workspace in the bedroom. So that's really cool. We were able to pass an image to the large language model, and it was able to figure out what the contents of that image was. So again, just an example that as long as the large language model that you're working with supports multimodalities, like in this case, image, so GPT can support images, then you can do this right within Spring AI. All right. So the next thing we want to talk about is kind of bringing your own data. Let's talk about kind of some limitations of large language models, right? So all of the large language models are pre-trained on a certain set of data. So if you were to say, when is your training cutoff? Although some of these don't answer now. Some of them just say, hey, I can search the web, so I have access to all data. But in this case, hey, my knowledge was last updated in June of 2024. So this means that just as the large language model itself, it has a knowledge cutoff. So if you ask it something like the current weather or about some event, my basketball team played last night and won, it wouldn't know about that. But it turns out there are ways to kind of augment this limitation of large language models. We can do a bunch of things. We can add data to the context window so that that context window that we talked about that we're putting tokens into, we can actually add some data to that to give it additional context. We can use something called retrieval augmented generation, which allows it, say we had a bunch of documentation or data in a database. We can say, hey, when you ask a question, go look in this database for similar information and get that out of the database and add that as context. We can have tools. So when I go ahead and ask it something like, did the Cavs win last night? Now, it wouldn't know that, but what you'll see up here is, I don't know if you'll see it, but it's thinking, if you look under the hood, it's going to basically go, okay, I need to search the web. So when you're using ChatGPT, it's actually using a tool to search the web now because it knows it doesn't have that information. So yes, the Cavs won last night because it was able to like search for that information. So there are all these ways that we can kind of augment the limitations of large language models. And so one of which is bring your own data. And in this case, if I were to ask this endpoint, can you give me an up-to-date list of popular large language models and their current context window size? Again, we are not on ChatGPT now, which is the product. We are talking to a model that has a predefined set of data. It won't know that. It'll respond. It'll answer this question with the data that it has. But if we were to look at that, it would be pretty out of date at this point. So what we can do is we can kind of send some information with it. And I'm saying here, here's a system message. If you're asked about up-to-date language models and their context window, here's some information to help you with your response. So I'm basically sending this as part of the request. And then if I go ahead and say, give me one LLM per company with the largest context window, it would spit out the correct information. So that's one way of augmenting the large language model, is by sending that in the context. Another way is, again, by RAG. If you want to look at the RAG example in the GitHub repo, you can. But another way is by giving it access to tools. So let's take a look at this one. I have defined a tool using the tool annotation here, and I'm giving it a description. So the description is very important. The description says, get the current date and time in the user's time zone. And what that description does is, as we send a user request, we will also send this tool description with it. So if we were to ask a question about the current date, the large language model will go, I don't know how to answer that, but I see you have defined a tool that I can go ahead and use. So it sends it back to us. We call the tool. This could be as simple as just getting the date. We could call a database. We could call another API in our organization. We could do a whole bunch of things with these tools. And then it will get that response and pass that back to the large language model. Now the large language model has that context to be able to answer that question. So I have an example of this. I'm using, again, just creating a chat client here. But now when I send this prompt, I'm saying, what day is tomorrow? Here are the available tools that you have access to. This could be a bunch of tools. Search the web, talk to GitHub, talk to some API. In this case, I'm just creating a new date time tools. I'm calling this and I'm getting a response back. So if I go over to my terminal here and I say 8080/tools, let's see if it can answer that. Today is April 24th, 2025, which means tomorrow will be Friday, April 25th, 2025. So it figured out, and you saw that was pretty quick. There is like this handoff, right? It asks a question, it sees it needs a tool call, sends it back. We call the tool, we send it back. There's this whole dance that, like, again, if you had to write from scratch, it would not be a lot of fun to do. And it turns out, like, again, the different LLM providers handle tool calls differently. So this is all kind of abstracted out for you. So just by defining this @tool annotation, this could be anything. I think I have an example in one of my repos of a weather call. Again, it is just a tool, and then you write your own class that maybe connects to like the weather API and figures out the weather for whatever city you give it. This is really how you start to build some really cool applications. This is being able to, like, any limitation of the large language model, you're able to provide more context or the ability to get more data based on what the user's asking. Cool. So I think I have one more here I want to talk about, which is my memory. So I'm going to, let's do this. Let's take this out for now and restart this. And what I'm going to do is I'm going to make a call to this. So I'm going to say 8080/memory, and I'm going to say my name is Dan, and it's going to say, hello, Dan, how can I assist you today? And I'm going to say, oh, great. Let me just ask the large language model, what is my name? And I'm sorry, but I don't have access to personal data about individuals. So what's happening here is when we talk to a large language model, the web is stateless, right? Like, we are not holding state here. And you forget this sometimes, right? Because if you're working with something like ChatGPT, if I went over to ChatGPT and did this, and I said, my name is Dan, and then I said, what is my name? And it will say, your name is Dan, because it remembers everything about the conversation that we're having. And so we need to build that into the application. And turns out it's really easy to do in Spring AI. So what we're doing here is we're setting a default advisor. We're saying, hey, I want to go ahead and add a message chat memory advisor. And this is just going to be an in-memory chat memory for now. There's also, in the latest version of Milestone 7, there's a JDBC chat memory. So if you want to store this information in a database, you can. And there are some more things you can configure, like how much context do you want to hold? Like, I want to hold 100 messages, I think, is the default. And you can also store like a user ID. So, hey, this in-memory chat is for this particular user. So if you have different users logged in using this kind of chatbot, you can remember memory for that particular user. So we restarted the application with this advisor. If I were to go ahead and do the same thing, my name is Dan. What is my name? Your name is Dan. So now it has that context. We are storing memory. It's able to remember those things. So I think that is it for my demos. Yeah, so that's it. I know we have 55 minutes. You can learn a little bit more about me at danvega.dev. I'm still on Twitter at @TheRealDanVega, and you can reach me at that email address or my personal one, which is danvega@gmail.com. And with that, we'll see if we have any questions.
Okay. Thank you, Mr. Dan, for
You're
taking your
welcome.
time. So far as I saw the comments, we don't have any question. As I said, everything is clear for now.
All right.
So
Well, either people are sleeping or I've done my job and explained everything really well.
wow, that was clear for me. Thank you so much. So as Huawei student developers and Huawei developer groups in Turkey, we appreciate your time to just giving your presentation here. So thank you so much.
No problem. Again, I appreciate you guys having me. Thank you so much.
Yeah, we will be dropping his accounts as LinkedIn. If you want, you just got had on the title on Dan Vega. Will be reach out his YouTube channel to learn more about Spring and Spring AI and Java also. So we'll be just giving edit to the description. So.
Cool.
If any, so right now, do we have any question, ladies and gentlemen? Just giving a time to them. Okay. Do you have anything to add, Mr. Dan?
No, I think really just I think I pointed this out in the presentation. M7 was the last milestone release. We are getting real close to GA. So if you are interested in the project, get in there, start testing it out, provide us feedback, and let us know how you're using it. I love to hear how everyone is kind of using it or what their experiences are with it. And if you have questions, always feel free to reach out to me.
Yeah. Okay. Thank you so much, Mr. Dan, for this crazy meeting. So
No problem. Thanks for having me.
thank you. We thank you. So we are ending the stream. So take care. Thank you so much again, once again.